Hi guys, today we're going to look at the last topic that's going to be on your test for this week, which is solving inequalities with no solution and infinitely many solutions. It's very similar to what we did with equations, where you either have a situation where there's no answer to the problem, there's no variable that could replace, there's no value that could replace the variable, or every number works for the inequality, okay? So in the first example, I'm going to go through trying to isolate x. I'm going to distribute. I have 2x plus 6, and on the left I have 6 plus 2x. And as I try to isolate x, I find that when I subtract 2x on both sides, my x terms all cancel out, and I'm left with just numbers. 6 is less than 6. So you ask yourself, is 6 less than 6? No, it's not. So if I end up with a false mathematical statement, that tells me that there is no answer to the problem, that there is no solution, which can also be expressed as 0 with a slash through it. All right? And so again, it's because the variables are all gone. I'm left with just numbers that say something that's not true. If you look at example 2, I'm going to distribute. I have 3x plus 15 is greater than or equal to 3x plus 10. As I try to isolate x, I subtract 3x on both sides, and I look at what's left. 15 is greater than or equal to 10. Well, that's true. 15 is greater than or equal to 10, so this tells me that all real numbers work for this inequality. All real numbers is every number works when you plug it in for x. And this can also be expressed in interval notation, which would be negative infinity to positive infinity with parentheses. Okay, this is your interval notation. On your homework, I'll say, if there's a solution, express it also in interval notation. Going on to example 3, we have, I'm going to combine like terms, we have 5x minus 1 is less than or equal to 5x minus 1. You know what? Actually, I just realized I wanted to change this problem. Well, I'll do it twice. So if I end up with this, 5x minus 1 is less than or equal to 5x minus 1, you could stop here or you could continue. You're going to end up with, if you subtract 5x on both sides, negative 1 is less than or equal to negative 1, which is true. So this would be all real numbers, right? Or negative infinity to positive infinity. Now, if you had a situation where the problem was, this is what I meant before, so I'm going to redo it. If the problem was written as 5x minus 1 is less than 5x minus 1, which is what I think I meant to originally write, this, if you subtract 5x, would give you a different answer. This would give you negative 1 is less than negative 1, and that's not true. That's false, because there's no equal sign. Negative 1 is not less than negative 1, and so this is no solution. Okay, so just be really careful that it's not about having the same number on both sides. It's about reading it with the inequality symbol. If there's an equal sign, if it's less than or equal to, it's true. But if it's just less than or greater than, then it's false, no solution. And then just be really careful that this is not the same as example 4, which we had talked about for equations, that when you end up with 9x minus 5 is greater than, I'm distributing negative 1 plus 8x minus 4. 9x minus 5 is greater than 8x minus 5. In this situation, let's say I add 5 to both sides, I still have x's in the problem. If I end up here, I'm going to subtract 8x on both sides to isolate x. I still have x in the problem. X is greater than 0. So 0 is different from the above situations, right? You still have x in the problem and x is greater than 0. That's a solution. It's saying x could be any number bigger than 0 on a number line. So like 0.2, 1.7, 10, 100, any number greater than 0. So in interval notation, that would be 0 to infinity. So just don't get confused with the number 0 as opposed to what we did up above with all real numbers and no solution. All right, so use these to work on homework tonight, and I will see you guys tomorrow. Thanks.